as we move through the chapter. Okay, so I'm asking you to take a leap of faith and just go, all right, this is how. I don't know why, but okay, we'll go with it. Okay, so this is calculus. Okay, so what? Oh yeah, that's it. Yeah. This is calculus. It's chapter 7 in book 4. Okay, so I'm in the green book, right? Okay, this is calculus. So if you watch The Big Bang Theory, they love talking about calculus because it sounds really amazing, right? Okay, but it's actually the rule is the easiest thing. As I say, we won't bother with the why. We're just going to go with the how for the moment. Okay, so differentiation by rule. Okay, so that's what we're doing here. We're differentiating. Calculus covers, for your leaving cert, calculus covers two topics. There's called differentiation and there's integration. So differentiation will be this year. Integration might be at the end of the year, but I don't think it'll probably be next year. Okay, so differentiating by rule. So it's called differentiating. So we'll be given a function. Okay. Right, okay, so we're given a function y equals x to the power of 3. Right, okay, and to differentiate it, right, okay, the rule is, right, if y equals x to the power of n, and the rule is in the log tables. Now the rule won't make sense until we do and dy dx is equal to n times x to the power of n minus 1. Right, that's the rule. Okay, and what we need is to differentiate it, and when we differentiate, we call it dy dx. I know it's like a foreign language, okay, just go with it. So when you differentiate it, you call it dy dx. And what you do is you bring the power down in front. So the power is a 3. Bring that down in front, leave the x, and reduce the power by 1. So 3x cubed becomes 3x to the power of 2. Is that okay? Right, that's 1. Right, if I had y equals x to the power of 4, when I differentiate, what would I get? Bring the power down in front. So bring the power down in front, it's a 4. Then you write your x and reduce the power by 1. So 4x to the power of 3. That's my answer. Okay? Is that right? And so on. One more. Right, y equals x to the power of 6. Differentiate dy dx equals, what I get? Anyone? 6x to the power of 5. Got the first rule? Yeah. Right, okay. Now, as an extension to the first rule, right, okay, if there's a constant in front of the x term, right, okay, and these rules, can I move it up? Are we okay? Yeah. Right, can I go? Yeah, okay. So if there's already a constant in front of the x, and you'll see what I mean in a minute when I show you an example, when you differentiate, when you bring the power down in front, you just multiply by the number that's already there. Okay. So that's like an extension of the first rule. Right? Examples. If we have y equals 2x to the power of 3. When you differentiate, dy dx is equal to, there's a 2 already in front of the x, isn't there? So when you bring down the power, you just multiply. So 3 by 2 is 6x to the power of 2. Does everyone see where I got the 6? I brought the 3 down in front. There's a 2 already there. 3 2s are 6. Okay? Right, so if I have something like 4x squared, what will dy dx be? Dy dx, what I do? What will it be? 8x to the power of 1. Do I bother putting to the power 1? 8 to the power 1, x to the power 1 is just x. Is that alright? Okay, so I could put the 1 there, right, but I don't have to, right? If I did, it's not wrong, because same thing, right? Is that okay? Yeah. Okay, same rule, or actually, yeah, I'm on the right, okay, so same rule. I'm not moving off this rule for the rest of the day. Okay, what if I had y equals 2x? Just y equals 2x. Bring the power down in front. What is the power? 1. Bring it down in front. 1 by 2 is 2. Right, and it's 2x to the power of 0. What is x to the power of 0? 1. So that's just 2 times 1, isn't it? Which is just 2. Right? Okay, shortcut. When you have an x term, when you differentiate an x term, you just get the number in front of it. So differentiate minus 3x. What will I get? dy dx is equal to what? Just the number in front of x. What's the number in front of x? Minus 3. Okay? That's just that. Is that okay? Right. If you were to differentiate a constant, so remember, a constant is any number that doesn't have an x in it. If it's got an x in it, it's a variable, right? Okay, as in it can change depending on the value of x. But now a constant has no x in it, right? So if you differentiate a constant, you get 0. So if you have y is equal to 7, differentiate it, what do you get? 0. Right? If you had y is equal to minus 3, differentiate it, what do you get? 0. Okay? So, sorry. Okay? So, anytime you have an x with a power, bring the power down in front, reduce the power by 1. Right? If you have an x on its own, right, like 3x, when you differentiate it, you just get the number in front of it. Differentiate a constant, you get 0. Right? Okay? I know it's like speaking a foreign language, but by the end of the chapter, this will be, right, grand. Be like, oh, please give us an easy one like that. Right? Okay, is that alright? Okay, so it'll just take a few minutes to get into it. I say a few minutes, that's all. Right? Okay, so, right, if I say example 1, sorry, I just put that down. Is everyone up with me? Anyone need that there for another minute? No. Right, example 1. So I'm going to say y is equal to 6x cubed minus 4x squared plus 3x minus 1. And the question is find dy dx. Right, when there's loads of different terms in the line, you just go across the line and you do each term separately. Okay, so you do each term separately because I just did individual terms up to now, but that's because when you have a big long line full of terms, you just do each term separately. So for 6x cubed differentiated, what will I get? 18x squared. Very good. So you bring the 3 down in front. 3 by 6 is 18. It was to the power of 3, now it's to the power of 2. Got it? Here, what will I get? Minus 8x. Bring the power down in front. 2 by 4 is 8. And that 2 reduces down to 1. Got it? Differentiate 3x. What will I get? 3. And differentiate minus 1. What will I get? 0. So I don't have to put in the 0. There's my answer. Right? Is that okay? Example 2. Y equals 2x to the power of 4 plus x to the power of 3 minus 3x squared minus x plus 4. Okay? There we go. Big long line. But as I say, you do each one individually. So differentiate it and call it dy dx. Right? Differentiate, you bring the power down in front. Right? So, and reduce the power by 1. Differentiate that term, what will I get? 8x cubed. Differentiate here, what will I get? 3x squared. Differentiate here, what will I get? Minus 6x. Excellent. Now be careful with this one. Differentiate minus x, what will I get? Minus 1, you normally get the number in front of the x. And remember, x on its own is 1x, isn't it? So you get minus 1. And differentiate 4, and what will I get? 0. Okay? Right. We just come from functions. And sometimes they don't call it y. They call it f of x. Isn't that right? Okay. Sorry. So example 3, right, okay. So sometimes they call it f of x equals. So they might tell you f of x is equal to x to the power of 5 minus x. That's me. Right, okay, right. When it's f of x, you know, when it's y equals, when you differentiate, you call it dy dx. Now, you don't have to remember this, it'll tell you it in the question. But f of x, instead of saying dy dx, when they say f of x, when we differentiate, it's called f dash of x. Okay? So it's just a different way of naming the same thing. We're still differentiating. Same rules apply. Bring the power down in front, reduce the power by 1. So what's, differentiate the first term, what will I get? 5x to the power of 4. And differentiate x, what will I get? Minus 1. That's your answer. Is that right? Okay. It's higher level, so sometimes it's not so straightforward. Example 4. So I go f of x equals, again, 1 all over x to the power of 3. Now, I can't deal with stuff underneath the line for the moment. In a while I'll be able to, but for the moment I can't deal with stuff underneath the line. So you use your rules of indices, right? Instead of writing 1 all over x to the power of 3, how can I write that? I could bring it upstairs and make it a x to the power of minus 3. Isn't that right? Now the rules of indices, you can move it upstairs, downstairs, just change the sign of the index. Right? So it was downstairs, I'm moving it upstairs and making it x to the power minus 3. There's a 1 there, so I can just drop the 1 because the 1 means nothing. If there was a 2 there, I'd have to make it 2x to the power minus 3. Is that alright? Okay, and then I just differentiate like before, f dash of x, what's my answer? Minus 3x to the power what? minus 4. Okay, and that'll get you full marks, but we normally don't leave a negative indice. So what we might do is just bring it back downstairs. So the minus 3 doesn't move, that's upstairs, it stays upstairs, right? X to the power of minus 4, I can bring that back downstairs and make it what? X to the power of 4. Okay? Is that alright? So there's your answer. Are we good with that? I'll take that as a yeah. Right, okay. Right, okay. Another example, example 5. Going to add in a little extra again. Okay, I'm nearly finished adding in extras, don't worry. So y is equal to 2x cubed minus 3x squared plus 4x minus 5. Okay, and there's an extra bit here. Find dy dx, like we just learned how to do, right, at x equals 1. Right, okay, so there's an extra bit here. Okay, so same first step. My first thing is to find dy dx. Okay, so dy dx, differentiate, what I get? 6x to the power of 2, yeah, minus 6x, well, plus 4, and that's it, isn't it? Because differentiate minus 5, you get 0. You all with me? Right, that's the step I learned a minute ago. New step, can anyone guess? At x equals 1, what'll I do? Everywhere I see an x, put in a 1. So the extra step is this at x equals 1. So you differentiate like before, but then the extra step, everywhere I see an x, put in a 1. So it's 6 times 1 to be squared minus 6 times 1 plus 4. And when you work all that out, it works out to be 4. And that's your answer. Is that alright? So extra step, if they tell me what x equals, I fill in for x, right? Okay, one more example. Y equals the square root of x. So this is example 6, sorry. Where was I seeing this? Square root of x into 1 plus the square root of x. And the question is, find dy dx at the point for, just give me a minute. Six. Okay, right. With me? Right. Okay. At the moment, we can't deal with brackets and whatever. We can't deal with stuff multiplied by. In a while, we'll be able to. But for the moment, if you see brackets, you need to multiply in. Right? Okay? Because you can't have brackets. Right? Okay? So before I start, I'm going to multiply in. So y is equal to, multiply into this bracket, what'll I get? Root x by 1 is root x, plus, what's root x by root x? X. Right, okay, right. Then I need powers, so I don't know what square root means, so I need to write that as a power. Square root of x can be written as what? X to the power of a half. That's plus x. Agreed? So then you do dy dx. So you bring the power down in front. So the power is a half. You leave the x and you reduce the power on the x by 1. So a half minus 1 is minus a half. Okay? Differentiate x and what will I get? 1. Right, okay. So what I need to do here is I need to get rid of this negative indice. Right? So that means dy dx. Right, I have an upstairs, downstairs here already. 1's on top, 2's on the bottom. X to the power minus a half is on top. So what do? Bring it underneath and make it x to the power of plus a half. Okay? Is that okay with everyone? So the kind of upstairs, downstairs is made already with the half. The 1's on top, 2's on the bottom. X to the power minus a half is on top. Bring it underneath and it becomes x to the power plus a half. With me? Right, and plus 1. Okay, I'm going to put the rest up here if it's okay. Right, so that actually means dy dx equals 1 all over 2 times the square root of x, because that's what x to the power of a half means, plus 1. You with me? Are you okay? Extra step. I've defined it at x, or the 0.46. Now, when they give you a point, right, all you need is the x term out of it. So when they give you a point, you just need, this is when x equals what? What does x equal in this point? 4. The 6, don't need to use it at all, right? Extra information, you don't need it, right? Is that okay? So you don't need the 6, all you need is the 4, right? So everywhere I see an x, so that's another way of saying x equals 4. They just gave me the point, so they gave me extra information, but I don't care about that 6. I just want to know x is 4. So everywhere I see an x, put in a 4. So dy dx at that point at 4, 0 or 4, 6 equals 1 all over 2 times the square root of 4 plus 1 into the calculator, press equals, that would be 2 2s are 4, quarter plus 5 over 4. Is that okay? Calculator job. That's a 4 in there. It looks a bit weird, sorry. That's a 4. Are we okay? Ready to try some? So I'm going to give you page 277. Let's have a go at one, 2, 4, and 6. So page 277, 1, 2, 4, and 6. Do you want a photo?